Hello, people. Welcome to the PAAC live stream of the Great Conjunction. Uh, you know that Jupiter and Saturn can be seen together in the night sky. But if you've noticed today, you can just listen to this feed and walk out with your earphones and phone. Because as YouTube, don't lock your phone because hello, people. Welcome to the PAAC live stream of the Great Conjunction. Uh, you know that Jupiter and Saturn can be seen together in the night sky. But if you've noticed today, you can just listen to this feed and walk out with your earphones and phone. Because as YouTube, don't lock your phone because it will just pause the live stream. But otherwise, you can just go out and see that Jupiter and Saturn have come so close that they almost appear as one star together. So this is a great conjunction happening almost after 20 years. It's happening after 20 years, and it happens every 20 years. But then every 20 years, they're not so close apart. Last time they happened, they were actually together. They were almost over 1 degree apart. So you could see them clearly as two planets that are very close by. And this great conjunction is actually happening and being visible at the same time after 794 years, because last time it happened in 1623, when they were actually very close apart by the same distance as they are today. They were just near the sun, so we couldn't see them. The event was happening during the daytime. But back in 1226, whatever the Great Conjunction happened, they were exactly this close as they are today, and we could see it. So it's almost 794 years after people on Earth are able to see this Jupiter and Saturn come together so close by. So yeah, we are glad you've joined us on the live stream. Coming up, you will see the feed of the telescope that we have fixed with a planetary camera, so you can see Jupiter and Saturn together. There may be a little bit of technical issues because the tracking might not be very precise, so there'll be on and off views. But as much as possible, we'll try to keep them in the field of view and show you the Jupiter and Saturn through the telescope at the comfort of your homes. Along with that, listening to this is very boring. Along with that, just watching this is very boring. If I just plainly show this to you and simply if I blabber at the background, you'll be quite bored. So yeah, I've got Shailaja ma'am with us today, who will be speaking about astronomy, these conjunctions and occultations as seen in history, and how she had to work without the aid of technology that we have today during her time, during her studies, how she actually would during her studies. And so Shailaja ma'am will join us today over voice, and even AP Bhatt sir is here with us today to tell us the beauty of these two planets. Nobody would have enjoyed this view as much as he does, because he truly loves these planets, truly loves the view through these scopes whenever they come together like this. So yeah, I'll be playing these audios because, of course, I wouldn't miss this program. I am setting the telescope for you right now, and AP Bhatt sir is busy in our college right now showing them to various people from around Udupi who've come together. And Shailaja ma'am is, of course, in Bangalore, and I didn't want to disturb her during this conjunction. So I called her in advance, both of them. I called them in advance, and they've recorded their messages and their discussions with me, which I'll be playing in a while. So tune in, people, and let me play this for you. We now have Dr. AP Bhatt with us, and he doesn't need any introduction. We have seen a lot of his talks, and we've heard about him enough. But yeah, nobody describes these beautiful planets like he does. So yeah, here's his voice in both English and Kannada, because he wanted to send out a message to all the people out there. So here's his message in English as well as Kannada regarding the beauty of this event.
ಆತ್ಮೀಯರೇ, ಒಂದು ಸಂಭ್ರಮದ ಕ್ಷಣಕ್ಕೆ ನಾವೀಗ ಬಂದಿದ್ದೇವೆ. ನಮ್ಮ ಜೀವಿತ ಕಾಲದಲ್ಲಿ ಇದು ಖಂಡಿತ ಸಂಭ್ರಮದ ಕ್ಷಣವೇ. ಯಾಕೆ ಗೊತ್ತಾ? ಈ ಸಂಜೆಯ ಆಕಾಶದಲ್ಲಿ ನೋಡಿ, ಆ ಪಶ್ಚಿಮದಲ್ಲಿ 2 ಚುಕ್ಕೆಗಳ ಒಂದು ಅಂತ ಹೇಳುವಷ್ಟು ನಮ್ಮ ಗುರುಗ್ರಹ ಮತ್ತು ಶನಿಗ್ರಹ 2 ಚುಕ್ಕೆಗಳು, ಅದು 2 ಬೇರೆ ಬೇರೆಯೋ ಒಂದು ಅಂತ ಹೇಳುವ ರೀತಿಯಲ್ಲಿ ಕಾಣ್ತಾ ಇರೋದು ಇವತ್ತು. ಅದಕ್ಕೆ ನಾವು ಈ ಗ್ರಹಗಳ ಯುತಿ ಅಂತ ಕರಿತೇವೆ. ತುಂಬ ಹತ್ತಿರ ಬಂದಿದ್ದಾವೆ. ಓಹೋ, ಇಷ್ಟು ಹತ್ತಿರ ಬಂದದನ್ನು ನೋಡ್ಲಿಕ್ಕೂ ಸಹ ಅವಕಾಶ ಬೇಕು. ಈ 20 ವರ್ಷದಲ್ಲಿ ಗುರುಗ್ರಹ ಮತ್ತು ಶನಿಗ್ರಹ ಒಮ್ಮೆ ಹತ್ತಿರ ಬಂದಂತೆ ಕಾಣ್ತಾವಂತೆ. ಅದು ಯಾಕಂದರೆ ಈ ಗುರುಗ್ರಹ ಸೂರ್ಯನಿಂದ ಸುಮಾರು 80-85 ಕೋಟಿ ಕಿಲೋಮೀಟರ್ ದೂರದಲ್ಲಿದ್ದು ಅದರದ್ದೇ ಒಂದು ದೀರ್ಘವೃತ್ತಾಕಾರದಲ್ಲಿ ತಿರುಗ್ತಾ ಇರುತ್ತೆ. ಸುಮಾರು 12 ವರ್ಷಕ್ಕೊಮ್ಮೆ ಒಂದು ಸುತ್ತು ಬರೋದು ಗುರುಗ್ರಹ. ಅದೇ ಶನಿಗ್ರಹ ಸುಮಾರು 145 ಕೋಟಿ ಕಿಲೋಮೀಟರ್ ಸೂರ್ಯನಿಂದ, ಅದು ಒಂದು ಸುತ್ತು ಬರಬೇಕಾದ್ರೆ 29.5 ವರ್ಷ ಬೇಕು. ಈಗ ರಾತ್ರಿ ಆಕಾಶದಲ್ಲಿ ಬೇರೆ ಬೇರೆ ಸ್ಥಳಗಳಲ್ಲಿ ಗುರುಗ್ರಹ ಶನಿಗ್ರಹ ಯಾವಾಗಲೂ ಕಾಣೋದು. ಆಶ್ಚರ್ಯ ಅಂದರೆ ಇವತ್ತು ಅವೆರಡು ಒಂದೇ ಪೊಸಿಷನ್ನಲ್ಲಿ, ಏನು ಹತ್ತಿರ ಬಂದವೋ ಅಂತ ಹೇಳುವಷ್ಟು ಹತ್ತಿರ ಕಾಣ್ತಾ ಇರುವಂಥದ್ದು ಒಂದು ಅತ್ಯಂತ ಆಶ್ಚರ್ಯ. ನಿಜವಾಗಿ ಆದರೆ ಹತ್ತಿರ ಬರೋದು ಅಲ್ಲವೇ ಅಲ್ಲ, ಹತ್ತಿರ ಬಂದಂತೆ ನಾವು ಕಾಣೋದು ಅಷ್ಟೇ. ಯಾಕೆ ಗೊತ್ತುಂಟ? ಇವತ್ತು ಈಗ ಗುರುಗ್ರಹ ಸುಮಾರು 89 ಕೋಟಿ. ಇವತ್ತು ಭೂಮಿಯಿಂದ ಗುರುಗ್ರಹ 89 ಕೋಟಿ. ಅದೇ ಶನಿಗ್ರಹ 161 ಕೋಟಿ ಕಿಲೋಮೀಟರ್ ದೂರದಲ್ಲಿದೆ. ಹಾಗಾಗಿ ಗುರುಗ್ರಹ ನಮ್ಮಿಂದ 200 ಉಂಟು, ಅಷ್ಟೇ ಆಳದಲ್ಲಿ, ತುಂಬ ಆಳದಲ್ಲಿ ಶನಿ ಗ್ರಹ ಉಂಟು. ಆದರೆ ನಮ್ಮ ಕಣ್ಣಿಗೆ ಹತ್ತಿರ ಬಂದಂತೆ ಕಾಣುವಂಥದ್ದು ಈ ರೀತಿ ಪುನಃ ಕಾಣುವುದು ಇನ್ನು 2080 ನಾವಂತೂ ಇರುವುದಿಲ್ಲ ಬಿಡಿ, ನಾನಂತೂ ಇರುವುದಿಲ್ಲ. ಹಾಗಾಗಿ ಆತ್ಮೀಯರೇ, ನೋಡಿ ಸಂತೋಷ ಪಡೋಣ. ಬರೀ ಕಣ್ಣಿಗೇ ಕಾಣುತ್ತೆ. ಅದೇ ನಮ್ಮ ಟೆಲಿಸ್ಕೋಪಲ್ಲಿ ನೋಡಿದರೆ ಅದು 2 ಗ್ರಹಗಳು ಹೌದು, ಗುರುಗ್ರಹ ಶನಿಗ್ರಹ ಹೌದು ಹೌದು ಅಂತ ಅನ್ಸುತ್ತೆ. ಈ ನೋಡುವಂತಹ ಈ ಸಂಭ್ರಮದ ಈ ಕ್ಷಣದಲ್ಲಿ ನಾವೆಲ್ಲಿದ್ದೇವೆ ನೋಡಿ ಖುಷಿ ಪಡೋಣ. ಇಂಥ ಅವಕಾಶ ಪುನಃ ಸಿಗೋದಿಲ್ಲ. ನಮಸ್ಕಾರ. ಫ್ರೆಂಡ್ಸ್, today we have a very rare event in the sky, that is Jupiter and Saturn's conjunction. We have a number of occasions in which there are some extraordinary events going on in the sky, but this one is very peculiar. See, every year we have opposition of Jupiter, opposition of Saturn, in which at that moment Jupiter is so close to Earth as well as Saturn is close, and hence it will be larger. It's a beautiful occasion. But the average distance of Jupiter from Sun is nearly 80 crores kilometers, and the average distance of Saturn is 145 crores kilometer. And they take different time to move around the Sun. A time taken by the Jupiter is nearly 12 years for one full rotation, and for Saturn it is nearly 29.5 years. And hence in the sky they will be at different positions. Today we have a very rare situation in which they are so close to each other. In this month we are observing the Jupiter as well as Saturn. They are coming closer to us. Actually, it's to us. They are coming closer. I mean, when we try to see the Jupiter as well as Saturn, we feel that they will coming closer. And today, it's a very rare event in which the angle between these 2 planets is less than 6 minutes. I mean, 0.1 degree. To see such a situation, we must wait up to nearly 60 years, and in 2080, hope we will get the same situation in which we can see these 2 planets. It's a very rare event. Every 20 years, we will see these 2. They are in which they will be close to each other. But this time, it will be so close that the distance is so small, and hence, when you try to see the ring planet as well as the biggest planet, Jupiter, which since we feel that they are not separate. They are attached to each other. It's a very rare event in which we are all enjoying now, and I wish you will enjoy the sky in your own way. Please enjoy.
So yeah, that was AP Bhatt sir talking about the beauty of this event. Again, I would stress that you listen to this audio, put this live feed, watch it, and if possible, if you can see the planets right now, go out and see them, because through the naked eye, it just looks like one object probably. So yeah, go out, but don't lock your screens, because that will pause this live stream and you'll miss out whatever discussions we are going to have next. For those of you who are interested, what you'll be seeing on the screen right now that we are streaming is through a planetary camera. A planetary camera is basically a device used to photograph planets with a very small field of view, so we'll get quite a good view. And we have mounted this on a 4-inch telescope. On a 4-inch telescope. If you've seen one of those PAAC infographics, then you would know that on a 4-inch telescope through an eyepiece, the planets look very small, although they look very close to each other. So we now have the recording of Shailaja ma'am, with whom we had a small discussion today in the morning. Shailaja ma'am, for those of you who don't know, was the director of the Jawaharlal Nehru Planetarium at Bangalore. She's got her PhD from Indian Institute of Astrophysics, and she has worked extensively on astronomy and getting astronomy out to the masses. One of the important work she has done is she has deduced and decoded many of these inscriptions that you find in temples, in old records and scriptures, where they speak about astronomy, because in most of these events, they usually recorded what could be seen in the sky so as to mark the date. So she has gone through these texts extensively. She's taken help wherever required and decoded the messages, the events within them, and she'll explain how difficult the process was. So she is here with us to discuss conjunctions and occultations. So yeah, let's listen to the discussion right now. So when we say in technical terms in astronomy, when we say conjunction, I always read they have the same right ascension. But then later you have an event where they come closer together, which we call it as the closest effect. And somewhere in some sites I've read when both of these happen on the same day, we call it an applause. So can you explain that a little more in detail? Like
there are two methods by which you can measure the east-west coordinate. There are two different kinds of coordinate systems. One is the right ascension declination, which takes the celestial equator as the reference. So you measure the east-west thing along the celestial equator. The celestial equator is nothing but the Earth's equator stretched to infinity. Now, the other method uses the ecliptic, that is the apparent path of the moon. So that is called the longitude, and that has a pole because it is inclined to the equator by 23.5 degrees. So the latitude measured along that will be different. So, but there is a very small difference between the two. It's not a very big difference, but for calculation purposes, it matters, especially when you are doing events like conjunctions and eclipses. It matters which one you take. So, the Indian texts had always been using the longitude and latitude system, that too uncorrected for precision. They did not want the precision correction at all. Even we thought that it works. And you need the precision correction only for calculating the declination. Only when that is needed, they will use it. Otherwise, they will revert back to their Nirayana system. Sayana is with the precision correction. Nirayana is without precision correction. So this is how they were doing it. So when you call it the instant of conjunction, the longitude of the sun and the longitude of the moon should be the same. That will be called the new moon. The instant, new moon is an instant. That instant is when the two longitudes are equal, and the full moon is an instant when the longitudes are exactly 180 degrees away. That is the definition of new moon and full moon. They are not days, they are instants. So it depends on which system is being practiced. But now we have computers and other mechanisms by which we can calculate all these things very precisely. And therefore, the right ascension is a better tool for these kinds of calculations. And so now the conjunction is defined in terms of right ascension. But there will be a small difference between the two. A very small difference.
So when they said Samagama in the old text, they were just talking about.
Now, I told you about the sun and the moon. The same thing you can apply to any two bodies. So when you say two planets, or the moon and a planet, are all in the same or in conjunction, it means the longitude is the same for them. This is from the old text. But now it is right ascension. If the right ascension of some planet is equal to the right ascension of another planet, they are on the same hour circle. Means if they rise at the same time and they set at the same time. But if the difference is less than 1 degree, that difference will show up only in the north-south direction. That means there is a difference in the declination. Sorry, I just mentioned that they rise at the same time and set at the same time. No, there is a small difference there also, because the declination is the one which decides the rise and set timings. So if there is a small difference in the declination, the separation, the minimum separation you see in the sky is nothing but the difference in the declination. So on 21st, if you see the minimum separation, that is in the north-south direction. That's in the declination. So now you can apply it to any two bodies in the sky.
Okay.
And you can choose a star also. Instead of a planet, you can choose a star. When will the star come in front of the star? That means the declination of the star should be the same as the declination of the moon or the sun or the planet. Then also it is a conjunction, but that has a special name because the solar system body will be in the foreground, star will be in the background. So it will cover the star. The star will vanish for a while. And that we term as occultation.
Okay.
Okay.
Yeah. So occultation is basically declination, where one disappears. The previous the object in the behind disappears.
The same declination. These two should have the same declination.
Okay. Ma'am, yes, when we spoke earlier, you mentioned that your early days in astronomy began with conjunctions and such events. So, can you tell us a little about those important events that you're talking
about? I was asked to record lunar occultations. That was one of the projects that was given to me when I joined the Indian Institute of Astrophysics. So every month we used to ask for the time. We would calculate beforehand because we would get the list from the Smithsonian Astrophysical Observatory. And we would provide the chart, and we would pick up only stars that are fairly bright so that we can record them with our meager equipment. The basic requirement was to measure the time interval of 1 millisecond. That was hard because the whole thing is over in about 25 milliseconds or so. So, Professor Bhattacharya had devised a special electronic device, measuring instrument, which was attached to a photometer. So it was photon counting. Now we are all used to digital things, but remember in those days, people were struggling with the analog signals. So in those days, converting them into digital every millisecond was a great achievement, and this instrument could do that. So the output from this instrument used to go to a teleprinter. There was no other device, teleprinter, which was used for getting telex messages. I don't know whether you know about all these things.
No,
these are all obsolete. So in the olden days, media, especially the Press Trust of India and other agencies, they used to send messages to all other agencies like All India Radio and newspapers through this Morse code kind of a device, which would print the news in their respective machines. It was a printer basically. So the printer part of it was used for transferring these numbers, the photons that are counted, and we would get a printout at the end of the thing. We would say end, and when we press the button end, it would print. So what we would have is a list of numbers. That is the photon count for every millisecond. And its capacity was only some 500. It couldn't print beyond 500.
Okay.
So the timing was very crucial. We would ask for the specific days, especially the first quarter of the month when the moon disappears in the dark edge. And when the star disappears at the dark edge of the moon. So those events we would list and apply for time, and the telescope committee would allot the time for us, say once in a week or twice in a week, depending on the demand for the telescope time. And then we would go there, set up the photometer, everything, and just 1 minute before the disappearance, we would go in for the time signals from the BBC.
Okay.
So the BBC has even now a time signaling system where the signals are audio, beep, 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 beep for every second, and for the minute it's a long second, beep. So we start at the long second, long beep, which is the starting of a minute. And then the machine will start counting. And the 1 meter telescope had two smaller telescopes attached to it for guiding purposes. One was 8 inch, the other was a 4 inch.
Okay.
Two of us would be sitting and watching through these two small telescopes with a stop clock. So the stop clock would start at the same beep. See, all this was done in darkness, so it was all mechanical. And then when the star disappears, we stop the stop clock. So from the round minute, from the starting of the minute to the disappearance, what is the time interval that we get in seconds? Okay, so this is how we recorded them. So there used to be always a small difference between the two of us, whoever was observing. And afterwards, we would take a printout. And when you print the information, you get a beautiful diffraction pattern with which one could measure the diameter of the star. This was the project. Okay, so every month we recorded something like 10 to 20 occultations, and if the lunar eclipse was available, then during lunar eclipse the advantage is that the moon is very dark, and because the moon is very dark, you can record the disappearance and the reappearance also for the same star. So after about an hour and a half, it will reappear from the opposite, diametrically opposite edge.
Completely
So
gone.
both the things we would record, and we would get two diffraction patterns of the disappearance and the reappearance. So now there is a software called Occult. If you download it, you can calculate. You can get to know about these predictions very well. But those days, it was coming from Smithsonian Astrophysical Observatory, and we recorded a good number of them. I remember even recording the stars of Praesipi. The moon passed through the clustered Praesipi, and there were so many stars getting occulted every minute almost. But the constraint was our teleprinter, because it would take 1 to 1.5 minutes to print those 500 numbers. Because of that, we were not able to record all the stars, but whatever we could, we have recorded. And all those things were used later by Mr. Mohin, I think, for getting the diameters of the stars.
Fine. Chaman, do you have any questions?
Yes, ma'am.
Yes.
Ma'am, when I heard about your works on decoding those inscriptions and all, I was very enthusiastic to have some suggestions about learning those things. Like, what are the basic requirements needed to do those?
Fortunately, most of the inscriptions are available in print form. Only now the history department people are on the lookout for new inscriptions, and whenever they get one, they go and it's a procedure. One has to go there and dig it out and clean it, and then put a paper, and they scratch it with charcoal or something like that, and get a copy made of the inscription. And once the copy is made, they will read that. Depending on the language to which era it belongs to, you have to consult experts and read out the information that is written there. And all this is being done by the epigraphy department of the Archaeological Survey of India. And there are few people who can read and understand this language. And fortunately, the
Telescope setting in progress.
material is made available online also. Okay, the report from the Archaeological Survey of India, they give this information. So only when you have a doubt, you need to go back to the stone and verify whether it is correct or not. So the transcription is usually available, and when the British started this work about 200 years ago, they even managed to translate the whole thing into English, and the volumes and volumes of this epigraphy are available, with which you can directly read the English part. So that is how I was able to read some inscriptions from other states, which was not Kannada. So that is also possible. So now, if your interest is in reading from the stone itself, you have to take a course in epigraphy. Kannada Sahitya Parishad is offering that, and even the BMC Foundation in Bangalore, they are also offering, because there are very few people who are interested in that. And Mythic Society in Bangalore is also offering that. That is one. But if you want to read the ones which are already decoded, deciphered, and extract the astronomical content which is sort of buried in them, then you can directly go to the English translations and the original Kannada or Sanskrit language details. Then you will get those things. Okay, so that is how I did. And I mentioned the name Geeta. She has done a course in epigraphy. So she was very helpful in reading and understanding some words there. And she knows astronomy. She has a telescope which she made with her own hands, and she goes around showing it to children. So because she was interested in both the topics, we were able to work together and produce that book.
Okay. And in these inscriptions, you mentioned a few times that they are all not actually astronomical texts, but they are whenever some donation was made to the temple, it was recorded.
Yeah, right. Their inscription. That is why it is a very boring job to read that, because if the sometimes this will go on for 4 pages.
Okay.
And the first page will be only talking about the genealogy of the king or whoever who is making this donation, praising him with all kinds of adjectives. And afterwards, then they are praising the person who is receiving the donation. Again, lots and lots of adjectives there. And somewhere in between, the information on the date is squeezed. So you have to read through the whole thing very, very carefully, very carefully. And then the details of the grant. Sometimes it can be a piece of land. Or it can be oil to be supplied to the temple. It can be in terms of measures of grains that should be supplied to the temple. In all these cases, all those details, giving the numbers and other things, weights, everything is given there. And in case of land, they gave the 4 boundaries: north, south, east, west. What are the landmarks within which the land is being given to the particular temple or particular scholar? The scholars were given these things. Okay. So in case if it is money, that is also given there. Usually it is the land deed. You can take it as an edict depicting the transfer of land to the temple or to the scholar. And sometimes it is given to distributed to a large group of scholars. That means more number of pages, because every scholar and his genealogy and his scholarship, etc., will be all described. So
to mark the date, they mention the sky or something in these inscriptions?
In the date, they will mention the Shaka year. Shaka is starting from AD 78. So that is the starting point. And then you have Samvatsara. Samvatsara is a 60-year cycle which we follow even today. Even today that is being followed. So you can simply work back and find out the year. And then it gives the name of the month. That is the lunar calendar month, Chaitra, Vaishakha, and all those things. Then it gives the phase of the moon, whether it is Ashtami, Navami, or Saptami. That information is available. Okay. And if it is an eclipse, they will mention whether it is a lunar eclipse or a solar eclipse. Then the small word, Videyute or Guru Rudu Sahite, this kind of a small word will be there. So that is the word we were getting. And it's very easy because when I said it is easy, the epigraphers, the British epigraphers consulted the local astronomers, and they were very quick in giving the date in the Julian calendar. And so you find the date already given there. And there will be an error only if it is Ashtami or Saptami or something like that, because that is difficult to decide. Between Saptami and Ashtami, how they decide, that's a very tedious procedure. It is called Tithi Nirnaya, and so many people have written books and books on that. But if there is an event like this, there is the occultation of Rohini and things like that, then we can fix the date very, very correctly. And all these calculations are done very meticulously. I said they use the method of iteration. So in the Udaharanam book, which I mentioned, for fixing the position of Mars, they have done 7 iterations. It's not a small job. They didn't have a computer. They had to do everything manually. And there is absolutely no mistake in the calculations. You can work back. Only when somebody copied them, you will notice that that person would have made some mistake.
Made some error, okay.
Because
And,
whatever error was there will get corrected in the next step.
Okay.
It's only a typographical error kind of a thing.
Okay. No, but in these inscriptions, occultations would mostly be mentioned with the moon. I mean, lunar occultation would be the important concept. Not occultation, conjunction. Sorry.
Yeah, that's natural because every day you have the moon next to a particular star. So the name of the star will be definitely mentioned. It can be Shatabisha, it can be Hasta, it can be any star.
Okay.
But when they specifically mention Rohini Vyatipata, it means the declination of Rohini was same as the declination of the moon, which means an occultation.
Oh, okay.
Okay, so this is how it was mentioned.
Oh yeah, in case of what is that conjunction I'm talking about? When we say, you said the moon will be next to each of the stars, which we consider as a calendar now.
They will mention. See, in one case it was Jupiter. And in another case, it was Mercury. They clearly said that that Mercury was with the moon. Buddha Indrair Yute. Buddha Indu. Buddha Indur Yute. This was the word that was there. So similarly, Guru Yuta. The moon was Guru Yuta. That means it was with Jupiter. So this is how you have to decode the words. But then they will mention the name of the Vara also, weekday. That will also have the name of the planets. So you have to really dig out whether they're talking about the weekday or whether they're talking about the planet conjunction. So that way I was mistaken with Saturn and Rohini on 2 inscriptions. It was actually Saturday. It was not conjunction. It was Saturday. But in one case, it was Shani Rohini Yute and Shukravare. So it was Friday, but Shani was with Rohini. This kind of distinction I could make out. So one has to read this information very, very carefully.
Okay. But in these historical sense, when we say every day we have one nakshatra assigned to the, which is closest to the moon, can we call it conjunction?
No. You cannot, because their nakshatra turns out to be a measure of time. Okay. So how do you measure the time? When you say Tithi, it has a certain interval. Okay. That is about 12 degrees movement of this moon. But when you specifically mention the name of the nakshatra, then nakshatra is the star that you see in the sky that is called as Yoga Tara. Whereas in calculation, nakshatra means a time interval. It's a time unit. Okay. Again, there when we are seeing the word Hasta there, are they really meaning the group of stars in the sky, or whether they are mentioning the time that we need to know? Okay. So, for example, I'll tell you. In the month of November, Kartika Masa, you should always have the full moon next to Kritika. Okay, always. But then last month, it was not near Kritika. Last year it was near Rohini. So then they adjusted it this year by putting one Adhika Masa. So this year it was back to Kartika with the Kritika. So last year, suppose there was a record written, then they will say full moon and moon next to Rohini. That means they are referring to the Yoga Tara, which is not Kritika. So we understand that there was a shift because of the need of Adhika Masa. So this is how we have to very carefully understand this. So now we wonder, how can the full moon be near Rohini? But it can be, and there was an occultation on a full moon day in the month of Kartika of Rohini. This is possible. So all such possibilities we have to explore.
Okay. So that occultation was the year before an Adhika Masa, roughly.
No, I meant there was no occultation year before last year, but
the record that you
600 years.
mentioned. Correct.
Yes.
The record you mentioned was a year before the Adhika Masa.
Not necessarily, because I don't remember if it was full moon. It may not be full moon. Okay. It can be any other day.
Yeah.
See, for example, if you take Swati, Swati is the star Arcturus.
Yeah.
The moon can never go near Arcturus, so it's impossible to have any occultation there. Right? So they fixed Swati because that's the nearest bright star they could think of for fixing the time.
So these are just markers to identify time.
These are markers. These are longitude markers for measuring the movement of the moon. So the moon takes 28 days to complete a cycle. So there are 27 stars. Okay. I have set up the planetary camera for 4-inch. Now, I wanted to ask you, when you declared that it is a planetary camera, what is the difference? Why did you call it a planetary?
The field of view is very small, so it focuses well on the planet.
And then these objects will have a disk. So all the planets will get recorded as a disk. So the angular size of these are large. So because you are interested in these objects, the stars can continue to look smaller dots. No problem. And similarly, there was a M camera. It was called M camera in Kavalur. So M, because it was basically used for Messier objects.
Fine.
Because Messier objects also have a larger angular size. Okay, so that is how I used that in a very funny way. It had only a plate holder. Those days people were using photographic plates. So instead of the camera, the plate holder will go and sit there. And you have to cover and uncover it for exposure manually. So I recorded the lunar eclipse, a sequence of that, and that because the field of view was fairly large, something like 18 degrees. The field of view was 18 degrees. So I calculated the positions beforehand on the previous evening itself. And I did not have a plate because there was a scarcity of plates. Photography plates. It had to come from the US. Kodak company used to supply it from US. Now, what I did was I put a photographic paper. You understand what is a paper? The paper is that on which you print photographs. That paper I cut it into the same size and fitted it, and I didn't have a shutter arrangement. So I would manually close the tube of the telescope itself, periodically every 5 minutes. And the exposure time also, I would count 1, 2, 3, 4 like this. And when it was a partial eclipse, I would give 1, 2 seconds only. But when it was total, I gave something like 10 to 12 seconds. And it was a beautiful photograph that appeared because I had to change the paper also in between through the 3 hours. This I had calculated beforehand, 18 degrees, what's the time needed and so on. And I had to adjust the thing so that in the rectangle it goes across diagonally. Now, all these arrangements I had done on the previous evening. And so on the day of the eclipse in the middle of the night, this was January 1982. I did this, and there were 3 photographs taken this way. The first one was terribly overexposed. I couldn't use it at all because 2 seconds also was too much for the moon. The one which I took during the totality turned out to be perfect without any problem. And the one later on, for the ending of the eclipse, everything would have been all right because I gave even less than 1 second, but somebody switched on a light somewhere there. Okay. It was a guest house very close to it. Very close means some 100 meters away. Okay. Somebody switched on the light. And that spoiled the whole setup. Oh. So the paper was useless. It became, whole thing became white. White. That okay. In that pitch darkness, even this kind of a light was good enough to spoil. Yeah. And that was a great exercise for me in learning how to use the telescopes, how to manage the positioning for capturing such events and so on. And that was called a M camera, which had a larger field of view. Okay. Suited for, so your so-called planetary camera also is perhaps meant for messier objects. Mm-hmm. Okay. Yeah. You try photographing messier objects with that. Okay. You will get beautiful images. Okay. So we'll never understand this pain of photographic plates and exposing and stuff. Because now you have everything digital. Yeah. And even if the photograph is spoiled, you can repair it. Yeah, exactly. Actually, ma'am, when I spoke to you last, I want people listening to this, I want them to hear this because today we have so many things like sky maps and apps. But you told me your own experience of making them, like in your early days when you didn't have all this. No. That is, see, there was only one map that was available, which was made in 1835 or so. It is called BD, Bahner Durchmusterung. That's the name. It was made by the German observatory, and that was generally available in all observatories. So they would put a transit instrument. That means the instrument can move only along the north-south, along the meridian. It cannot move in the east-west direction. Okay. So somebody would sit looking through the eyepiece, prepare a chart, note down the time, and the chart will mark the stars in the field of view. 1 degree is 4 minutes. After 4 minutes, this would have moved away, making way for the next set of stars. Okay. Then they will mark that also. So this way, the entire 24 hours was made. You can imagine how much of time must have been spent on this. Yeah. And then this is, let's say, at 0 degree declination. Okay. Then they go to 1 degree declination, repeat this. Then they go to 2 degree declination because you have to wait. There is no other scope, no other way to manage this. So they were doing this. So the field of view also was 1 degree. And then they put the whole thing together in the form of a chart. And that was called Bonner Durchmusterung. And on that chart, they measured the right assumption and declination. See, once you convert it to a graph sheet like format, you can read out. And that was tabulated and provided. So along with this BD chart, we used to have 3 volumes giving the right assumption and coordinates of stars. And this was restricted to 6th magnitude only. Okay. This was up to 6th magnitude. So suppose there is a nova. There is an information on a nova. They give the coordinates. Then we work back the coordinates, applying all the corrections to 1835. Okay. And then go to this chart, copy the chart onto a tracing paper. And then, because we are not supposed to use pen on this chart, you will create an extra dot. And you cannot Xerox it. Those days, there was a machine called Core Stat. It was not Xerox. They used to use carbon powders, chart carbon powders for making copies. So on that tracing paper, we would mark the position of the nova and carry it to the observatory. Okay. Well, if you want to observe Uranus or Neptune also, we did the same thing. Because we know the position from the ephemeris and prepare a chart and carry it and look at it. Look at through the eyepiece of the telescope, identify star by star. Then the extra thought that you have at the center of this group is the planet or the nova that you are. So this is the exercise we were doing. And now all that is redundant. You just put the coordinates and it takes you there. Correct. In fact, 2 days ago. I did the same way.
Okay, that is what, ma'am. That is what I wanted my students to know. This 2 days ago, I was showing them some stars and telling them about some constellations, and they had this app which shows them the star as they move their phone. And he had the constellation drawings and linings and names marked. And then he's standing behind me and saying, "Whoa, what beautiful constellation!" So when I told him to disable all the settings and just see the stars,
So when I take the students to Kavlur, whenever I did that, I would ask them not to use this app.
Correct.
Not use this, because it is something like I'm teaching you how to multiply 2 into 3 to get 6. And you use a calculator and get the.
Correct.
No, that's not
I
correct.
understand. If you have difficulty with light pollution, at least use just the stars in that, not even the names of the stars.
Right.
We have a big planetary grouping of sorts coming in February. So I would love for you to shed light on that before news channel people will mislead us. So what is happening and astronomically, how nice is the event?
No, this will be a grouping. This is not a conjunction. This is a grouping only.
Okay.
And we had several such groupings earlier also. The one which created a lot of news was the one that happened in the year 2000. In 2000, in the month of May, almost all the planets were there with the sun.
Okay.
In the month of May. So I remember this magazine called Taranga carried a cover page article on Pralaya. Some disaster is going to happen, and that particular copy was sold like anything, and even Xerox copies were sold.
Oh, okay.
Because that was a very misleading article. This is a natural consequence of things happening. I remember at that time we made a scale model of the solar system and put markers in our basement area to show how the planets are distributed and why it is impossible to have them even in the same plane. They are not in the same plane.
Correct.
There is no alignment. It's only the virtue of our line of sight that is happening. So that is important. So, and if you involve students to make this, they themselves will understand this, and when it happens next time again, they will remember that this is the way to teach people. In fact, the very first planetarium in Netherlands was designed on one such occasion when there was a planetary grouping.
Okay.
This was in a place called, it's near Hague in Netherlands. I forget the name. It ends with GA and some funny name. Okay, there was this person, Isinga, who was hurt by people talking all nonsense because of the planetary grouping. And some rationalists wanted to um, kill the nuns. They said that they are responsible for some bad thing that is going to happen and so on. Then he created a planetarium kind of a device where it detected the planetary motion on his own terrace. He devised the entire mechanical arrangement for that, which is still running. It is even now running. And his name is Isinga. Eisinga. If you Google, you will get it. And that mechanism is still working. And he created this to disseminate the idea that planetary groupings are a natural consequence of this. When he made this, planet Neptune was not discovered.
Oh, okay. Okay.
That is not there in his model.
Okay.
That is a very interesting thing. And nothing happened. No catastrophe happened on any such occasion whenever there was a grouping like this.
Okay.
So I think you should bring this to the people, and you can use the occasion to see all the planets together. That's all. You can have a session and you will put 7 telescopes or 6 telescopes.
But sun will be with them, no? This time.
Sun with them. That is the point. So it should be either at dusk, say 15 days before,
Correct,
or
correct.
dawn.
Correct. With clear horizon, I think we can have a great program during that.
As we are having now.
Okay.
These
Otherwise,
two,
it will just be.
these would have gone to the dawn sky by then.
Correct.
After the conjunction, no, I said the conjunction with the sun. So Jupiter is heading for the conjunction first. So we can actually calculate when it is going to happen roughly. Maybe in another month or so. And then by February, it will be in the dawn sky. And the same thing with Saturn. Saturn also will have the conjunction a few days later. So both of them would be in the morning sky together.
Along with Venus also.
So you can predict. Capricorn, they continue to be in Capricorn. And when sun crosses Capricorn, you will have it. That is after the month of Makara. That is sometime in February. So you can calculate or you can guess even without the help of any calculator. If you are a keen observer of the positions of the planet.
Okay. Yeah, that will be a good challenge. Otherwise, it's just magazine sales in February that we'll see.
Yes.
Okay. Thank you so much, ma'am. It was a great session.
Okay, thank you.
Ma'am.
Thank you, ma'am.
Okay, guys. So that was basically the recording of all the programs we've had planned. So yeah, let's just look at the Hello, people. Welcome to the PAAC live stream of the Great Conjunction. You know that Jupiter